John Berryman of Arcturus Labs, and many other things that I hope he'll tell you, so I don't have to remember them all.
That's true. All right. There is a little bit of an echo up here. FYI, this is a talk that is aimed at maybe a little bit unusual crowd. So if you haven't read the screen, a lot of people here know a thing or two about lexical search already. This will have some more introduction to lexical search, but there's also, I think it's really targeted at people who are doing a lot of RAG applications and just follow the default of semantic search. So just FYI. You won't hurt my feelings, and literally I cannot see if you leave right now. So lexical love, rediscovering the power of lexical search in RAG. Hi, I'm your host today. I'm John Berryman. Just a little details about me. I started out in aerospace engineering, and I love the math. I love the data. I love the software, but I didn't particularly love anything else. I mean, it was just cool, but with math and software, you can do anything. So soon after that, I got into the realm of search that we are immersed in today. Got the opportunity to write a book with that dude right there. Swore, my God, I'll never do that again. Ended up working for GitHub. I helped create the next generation of search 2 generations ago, so it's kind of already done its thing. And I was in a very fortunate position to be an early production engineer on Copilot. I was probably about number 5 or 6 on the team at the time. So I learned a lot, which gave me the opportunity to write another book. Did it again. And then since July, I have been an independent consultant for Arcturus Labs. Please find me at www.arcturuslabs.com. Yeah, there's my disclaimer. All right. So semantic search. That's the way you do RAG, right? It's easy. All you have to do is take your documents, chunk them up into little segments of information. You use some sort of BERT-like transformer model to embed them. Dump those in a vector store, and at query time, you just take the query, do the same process, match the vectors, dump that into the prompt, and Bob's your uncle. It's a really easy way of implementing RAG. This is, and it's cool. Unlike old-fashioned lexical search, we're matching on meaning. And there is some truth to this. Semantic search has some really cool qualities, but it also comes with some challenges. So, for example, it's impossible to find certain types of things in semantic search. Semantic search is great for looking for meanings, but if your meanings are not something that is easily encoded in the vectors model that you're using, then you're looking at retraining the model. If you're looking for something that's really specifically based on terms, product IDs, people's names, that's not going to be represented in a vector model unless they're amazingly famous individuals. Phrase matches. You can't say find the movie with this title unless it's a very semantic title. You're just going to get lucky. And if there's any new jargon that has been introduced since the embedding model, it's not likely at all that the embedding model is going to encode that. So your information is just lost. It falls flat. In addition, you guys probably know about lexical search enough to know how easy it is to monkey around with relevance and change problems when they arise. What do you do when semantic search falls flat in terms of relevance? You're probably looking at, the black box of vector search starts to look like the deep black of the abyss. It's like you're going to have to retrain this thing in order to improve relevance, and the turnaround rate on those type of experiments are so much longer than tweaking knobs in lexical search. And also one of the things that I'm going to complain about for the next 30 minutes is filtering. There is filtering with semantic search, but it's really clunky. It's something that I don't think that there's been a technological solution for. So with all the smart people here, one of the things I plan to do this week is to like ask you like how is this problem getting solved. But with semantic search, it's harder to say, find me the nearest document in the meaning space, but also filter by these things. You end up having to do pre-filtering or post-filtering. Let's get into it. How do you filter? Well, one way is to do the semantic search and then filter. So you make the query, map that to your embedding space, and then you get the nearest documents. You get, I don't know, nearest 10, nearest 100, whatever you want to do. And then you say, okay, I'm going to take the attached metadata and post-filter these things. But the problem is you run a large probability in certain domains of filtering out everything. If I'm looking for diamonds below $50, I'm looking for cheap diamonds, then that's a place where you're probably going to have lots of results that are semantically similar to diamonds. But once you apply a filter, you're going to run out. You have to go back to the semantic search, find the nearest 1,000, and it becomes complex. All right, well, let's just switch the location. Maybe we do pre-filtering. It's kind of like hybrid search, right? We could actually even use lexical search and grab a bunch of items and then use semantic re-rank, not semantic search, to filter it out. And that's problematic for kind of the opposite reason. That whatever the filter is, it's already not semantic in the same way that semantic was advertised to be. You're not matching on meaning space. And then semantic re-rank is not the same as semantic search. You're not using this fancy, really efficient, really neat data structure, hierarchical, navigable small worlds to get it right. You're not using that. You're doing something that is just directly taking all of the vectors and doing Euclidean distance or cosine, sorting them and returning them. It's a brute force approach. If you've got thousands upon thousands, millions even vectors that was in your search index, you're not going to be able to re-rank all those. Pain. That's why this slide is red. So in this talk, we're getting ready to reintroduce lexical search. If you already know lexical search, this is going to be a good deal of review. But then we'll take the cool bits of lexical search, and I'll show you how we can build RAG that in some ways is super powered over what the de facto standard of semantic search poses to be. We'll discuss some problems because even though I'm definitely waving the flag for lexical, our baby is not without its problems of its own. And I'll point towards some of the things that I found towards hybrid search that is really resolving this problem. But there's the ... of it's not quite there yet. And that's where our Q&A could be me asking you guys, like, what, as experts in the room, what have we found? All right, let's learn lexical search really fast. Indexing, searching, and result organization. All right, lexical indexing, lexical search has all the typical data types you'd expect. Numbers, floats, dates, even some exotic things like geopoints, geoshapes, time intervals. You can do scheduling stuff. There's really cool stuff. But the star of the show, of course, is text. Text is treated much differently in lexical search than vector search, whereas text in vector search is going to be tokenized and turned into a vector, just a bunch of numbers representing meaning. With lexical search, we get a chance to keep it basically as text in some ways. So it makes it a lot easier to wrap our brains around what's happening. If you start out with the canonical search example that everyone uses, the quick brown fox jumps over the lazy dog, then lexical analysis is the way that you can process a sentence into whatever tokens that you want it to be. This is one of the first knobs that you have on tuning your own relevance. Character filtering removes diacritics, lower cases, everything. Tokenization splits on white space and punctuation, or whatever you want. Stop wording removes like the words that don't carry much semantic value. And stemming is kind of our way of taking words that lexicographically are different, jumps, jumped, jumping, laziness, lazier, and mapping them down into a space where, like, you can type in any of those and match own documents with all the others. But part of what makes lexical search, a really efficient algorithm is the way that we actually do the indexing. Because let's assume that we've got our document we just looked at. It's already been tokenized. In order to make lexical search fast, we invert this relationship. For document 12, we have these 3 tokens. For document 43, we have all those tokens. But we can invert it, and for every token, we list the postings list. We list all of the IDs of the documents that's going to match. This is kind of the special sauce that makes lexical search super scalable, super fast, because apparently I'm going to show you that on the next slide. To be continued. But anyway, this is what the index looks like internally. It's just a mapping from all the words to all of the documents that contain those words, those tokens. So we started at indexing. We're going to go to querying and result organization. At indexing, we're starting to see the differences that you need to understand between semantic and lexical search. With semantic search, the ETL process is a bit more involved because it's important how you chunk. You have to, the vector embeddings models that we have are like 8,000 some odd tokens that fit in a window. And so if you go over that, it just errors out. You have to figure out how to split it. You have to make sure that you're not splitting it on, the middle of a paragraph, something like that. So semantic splitting. And oftentimes it's good to add more information into it. Like the last speaker in here was kind of modifying the information from what we actually index. With lexical search, there's no chunking. So in some ways, you have to understand the analysis process, but in some ways, the ETL is kind of built in. You just say, index this. Semantic search, the index is often quite a bit larger because it's not that you just have the document you're indexing, but all the chunks are encoded as fairly large, floating point vectors, and so it's actually quite a lot of information that goes into the index. A lexical search index tends to be a bit smaller. Probably my biggest complaint at the level of indexing is once the data is indexed, the data is completely opaque in semantic search. It is a vector. The qualities of the semantic vectors. If it's nearby, then it's going to be nearby in semantic space, but that's kind of all you know. You don't really know what this random string of numbers means. Lexical search, at the end of the day, basically, you're still looking at something that is a string of letters that you can read. You can understand why matches were made because it's still word-like. Now, at the searching level, we have this cool inverted index structure, and what I was getting ready to say just before the interlude there was this is the power that makes lexical search so fast. If you wanted to find all documents that match Fox, then rather than when I was getting into the search field is like, how is it magic? Is it looking through, grepping the whole document? No, it's already effectively done all the single word searches possible, right? If you wanted to look up, Boolean logic on this stuff, Brown and Fox documents, you just take out multiple postings lists and either union them or union. What's the opposite of union? Thank you. I'm missing the word for some reason. But it's not just a Boolean search. It's the scoring is super important too, and this is the tunable thing. Scoring is based on TF-IDF, BM25, but effectively a mental model of TF-IDF is a really strong intuition here. The more times a term occurs in the document, more likely it is to be related to your search, and the more times a term occurs across the corpus, the less important the term is. So keep those things together, and that's a good way of scoring which documents are the most important for the whatever search you're looking into. And BM25 is typically thought of as just a something per field, but when we're dealing with inventory at a clothing store, or talking about music list, or talking about whatever you're searching on, it usually has multiple fields. So with the cool thing with Elasticsearch, with Solr, with OpenSearch, is you have all these knobs to adjust the importance of a given field in there. So at the searching level, semantic and lexical search, we're starting to stack up more differences. Semantic is searching by approximate nearest neighbor, which is a good proxy for searching by meaning if the vector embedding does actually embed the space that you're talking about. With lexical search, we're matching on tokens, which sounds like it wouldn't be as good, but oftentimes I mean, the tokens are tokens for a meaning. The tokens are tokens for a reason. In English, we have commonly say the same things when we intend the same information. And so lexical search tends to be actually pretty good, even though it is just searching on tokens. The extra benefit over semantic in this case is also, if you really, really want to search by tokens, phrase matches, stuff like that, you can do it. Searching and filtering happens in different steps with semantic. With lexical search, everything happens simultaneously. Effectively, you can use multiple indexes in parallel, in effect, with the posting list. Relevance is distance, and you don't get a choice with semantic search. That's just kind of it, or cosine similarity. And with lexical, you can debug and apply boost, and you have all sorts of fun things you can do at the time of your search. Now, with the third chapter in our quick education of lexical search is all the cool stuff that you can do with the results. Obviously, the search engine result page has been the same for 20 years, 30 years, and whenever you search for vector search, whenever you search for anything, you'll get your typical top-end documents, and this is going to be the same with both semantic and lexical. But a cool superpower that I haven't heard anyone talk about for RAG is what you can do with the aggregate analytics that comes back from lexical search. With semantic search, you're going to match the nearest 10, 100,000 documents, but you really don't have a good clue about where that cutoff line is. And the index itself is not well set up for understanding what else is attached to these documents as you traverse through the vectors. Lexical search, on the other hand, whenever you're quickly streaming down those posting lists, grabbing the top 10 documents, you also have relatively easy access to all the other information that's associated with these documents. And like with Amazon or any e-commerce website, that's what you get on the right side, the left side of the page. It's your facet counts. And what do these do for you as a human? They allow you to kind of intuit what is left unsaid by the top 10 search results. With the top 10 search results, you can say, okay, I can get an idea of the most relevant stuff. With the facets, you can see what else might be there if only you could subdivide and look at it. And then if you want to go down that route further, it's a very, very, very deep rabbit hole, because you can do all sorts of fun, amazing things with aggregations. If I was writing a RAG for Airbnb, then I would create little friggin' histograms of like the whatever's left over in the housing for a particular search. You can do averages, min, max, histograms, cardinality, nested results, all sorts of neat stuff that you can do that I don't think has been adequately researched. Lexical search also has snippets. Kind of think of this as search time chunking. It's chunking specifically to the pieces that are the most relevant. Highlights, I tossed it in there. help me think of a good use case for it. It's kind of cool that we can do that with lexical search. It's harder to do this with semantic search. Okay, so here's our different slides for results. For these first two chunks, it's kind of the same. Semantic search, you a priori chunk the documents, and the documents can be retrieved with their associated metadata. With lexical search, it's a different shape, but it's kind of the same thing. Lexical search returns the full doc, but with the snippets, you kind of get the chunks. You also get, whatever fields returned. So it's very similar. But one key difference that we'll look at when I build the RAG app here in a moment is with semantic search, you don't get these cool aggregations about stuff. You don't get this information about what else could be if only you knew how to slice and dice the data set more. Lexical search, that's one of its unspoken superpowers. All right, supercharging RAG with lexical search. Let's create a simple scenario. We're going to create a chat assistant that allows users to navigate in inventory for home items. I'll add an extra little thing just to exercise this piece of lexical search that I'm kind of weighing in on. Is all the items have some sort of limited availability. You're in a certain state, and you can only get certain items shipped to you if they are available in that state. So we require an extra filtering step. Some of you probably already guessed where I was going with it by the by the example, but we'll be indexing the Wayfair annotation data set. If you guys haven't had a chance to play with this data set, it's an e-commerce product data set by Wayfair that is just really just a rich source of information. It's got, I think, it says it there. It's got 43,000 home items, appliances, furniture, stuff like that. And the data set is used as kind of a benchmark for relevance algorithms. But I've been using it for a really fun data set to toss together examples like this. We have several fields of interest in our data set: product name, product class, product description, rating count. But I've also added, it's fake data, but I've added an availability field that allows us to say what state these items are available in. So it's a keyword field that's just an array of state names. All right, when you're building out the application, we need, in Python, we have the high-level search function. It takes these parameters, it's pretty straightforward. Got the query string itself. You have the availability, whichever state the user lives in. You have product classes, which is that's the one facet. We're also going to think about the facets on the side of the search results. So product class is a way for the LLM to start subdividing the search. You have the rating and you have the number of results. So pretty typical stuff. This is how you would set up the search in Elasticsearch as an example. Just like plug in the query string, boost phrase matching a little bit higher. The idea of being able to apply different types of boost is kind of one of the cool things of lexical search, obviously. And if the user provides any of these other parameters, then we just augment the Elasticsearch query to make sure that we're appropriately filtering based on rating, product availability. And then the output of this Python function, I've taken the Elasticsearch results and I've just dumped them into a format. This is what the LLM is going to see here in a little bit. It's the obvious stuff. Product name, product class, array, potentially. The product description and the average rating. Enough to give the model kind of an idea of what's going on here. But also, I've been alluding to how cool it is that lexical search has the ability to do aggregations. I've just created a simple facet field for the product class, and in the way I'm organizing this to present to the LLM, is really straightforward. I'm just saying, hey, guess what? Product class, you have, 553 desks. These different things. I've got counts associated with the top, 8 or so categories. Okay, so now we're getting into actually the meat of it for the LLM implementation. One of the things I always like to harp on whenever we're building a RAG application is in so many blog posts, in so many like YouTube videos, the drive-by commentators talk about RAG as if it's a thing, as if it's a big black box. You don't have to worry about it. You just take lane chain and like in 15 minutes you've got your own RAG application. That's a horrible way to look at it, especially for this crowd, because you know that it's actually two things. Retrieval-Augmented Generation is retrieval and generation. It's not, if you make it one thing, then you're resigning yourself to just to have no alternatives when something breaks. If it's two things, then all of a sudden the black box becomes transparent. When you have a problem, you can figure out, is this where my search is going wrong, and I can tune the search in the ways that you'll see here at Haystack, or is this I'm taking the results and presenting it incorrectly to the large language model, or is the large language model just like getting confused? It's in the wrong domain. We need to add different like a system message or examples to clarify how it should work. So part of creating the LLM search tool is telling the LLM model what tools we have to work with. In this case, it's simple. We have one tool called a search catalog. Now, the model looks at this just like a human would to infer how it's going to use it. So it's important, I won't read the description, but it's important to have a pretty vivid description of how things work, how this tool is expected to react to different things, so that the model can anticipate it. The model should understand that the search catalog function has different arguments, different properties associated with it. Query string, product class, minimum average rating, and it should also understand what these things apply. So we have very verbose descriptions of our functions just to make sure that the model has a reasonable understanding of what's going on. And then we actually give this function to the model. The model is going to say, I want to call this function, but when that comes back in the API, when that comes back in the application, we've got to actually transfer that to the real API that we're talking to. In this case, I've created a tool lookup where basically I'm taking the high level search I introduced us to in the previous slide, and I'm currying it, and I'm adding the user state as a permanently fixed parameter here. But effectively, what this search catalog ends up becoming is exactly a function that has these three arguments. All right. Now let's assemble the full application. This is a RAG application because we have retrieval in it. It's also agentic AI. Everything is kind of the same thing. All agentic AI is a set of instructions, which is exemplified by the system message here. Typically, a bunch of tools, which we just finished talking about, and a loop. And that's kinda, without oversimplifying it too much, is kind of all there is to like agentic AI. The fortunate thing is that it's actually pretty simple. When a user has a request, we send that into the model. The model might choose to when the user sends in a request, we build a prompt based on information that we know about them and information we directly have about the request. We give that to the model. The model might choose to execute a tool. If it does, we get the response back from the external API, put that back into the prompt. This gives the model more information to understand what to do. When the model is satisfied that it's got all the information that it needs, it composes something that is in the voice of the assistant and gives that back to the user. But it's really not that complicated. Our system message in this case, our instructions, is also similarly straightforward. You're a helpful assistant, and you can find products in the catalog. And I just give kind of instructions about, here's the steps you take as you research through the catalog. Once you get the information back, here's the steps you take in presenting this to the user in a way that will make them smile. All right, so here's my demo. I've kept it in PowerPoint where it's much better behaved. But this, what I'm going to show you is a good representation of the things that you can see running this app. I do have it somewhere in the background. Here's our friendly assistant from the year 2027. Hello, how can I help you? Well, my back hurts from sitting here in this chair all day. So the question is, what's going to happen right here? Well, the LLM is going to see that it has this search tool. It's going to see that the user has a complaint. It's going to look at the instructions and say, okay, it's my job to help the user, so I'm going to kind of read between the lines, and I've got to use this search application. And so it's going to make a search. Now, it could do any number of things, and so we'll talk about this for a couple of slides. The default thing that it might do is just make one search. But I have coached it in the system message to be like, you don't immediately know everything about this catalog. Search around a little bit. You can do several parallel searches, and we'll pull back all the contents and feed it back to the model so that it can represent the information better to the users. The model, I've seen it do this before. It could do one search. Because the model has the choice. It can just say, I know what you need. You need a standing desk. It can do one search, and then as soon as that information is stuck back into the prompt, the model can look at it and be like, oh, okay, I'm learning more about the inventory. I'm going to make another couple of searches to gather the information that I feel like the first search implies I need. So it can do that as well. Oh, and I've kind of missed this point. One of the cool things that is actually implicitly happening here already, because we are using lexical search, this information is already got the filter. It's already filtering by whatever is available by state. So we don't run into some of the issues I introduced early on about pre-filtering or post-filtering on very large data sets. You already get away from that for free. Another thing that the assistant might do at this point, it can run this first query. My back hurts, so I'll get a standing desk. It can run this first query. And then when it looks at the search results, I'm giving it the top 10 results to match whatever the query is based on lexical search. But we've also got this cool superpower underneath. We have aggregations, which in this case is just a facet count. But this is a place where the model can say, it might look at the top 10 results and see interleaves things that aren't all like desk. It can see office chairs, area rugs, some of these other hits might have made it into the top 10 list. So it can choose to do things like add an extra parameter for the product type, desk, automatically filtering down. May I recommend this Standtastic adjustable standing desk? Yeah, so I only want the best desk. It can also choose to use the other parameters. And so now we've already got another type of filtering that in this case, instead of us automatically filtering down to availability in the user location, the model itself is tossing on a filter. So it's no longer just a quick search over just matching meaning. We still have the matching meaning. We've sub-selected to like a better semantic space so that we can explore more easily. And we also added extra filtering as requested by the user in real time. So it's kind of exciting. All this AI stuff is very cool, but the ability to automatically have the agent understand the inventory, navigate through it itself is, I think, something that is a bit underutilized. And there's plenty of other cool ideas that you could do with it. One example is right now our query parameter, as I've described it to the model, is keyword search. It's what you would type in typically in Google. But there's no reason that you can't say in the system message, hey, guess what? This query parameter also supports loosing text. The model itself has been trained on everything on the internet. It's seen a lot of loosing text. So I don't have any doubt that if you give it enough information in its system message, it should be able to put things together to filter down to fields itself, and maybe even do some interesting things like boost and do ranking type stuff. In principle, if the user says, I prefer lower price desks, then you might could have it boost by that as opposed to directly filter by that. Naturally, when we get into that type of nuance, I'm sure there's devils in those details, but it is a cool idea. Models are getting more capable, and I think they're doing better with following instruction. And so this is something I think we can do in the near future. All right. As much as I like lexical search, it's not all roses. There are problems as well. For example, I know that this is a dress. You know that this is a shoe. We all know that this is a dress shoe. But lexical search thinks this is a dress shoe. Yes, the bane of my existence, the bane of my career has been this one example. And that's because, as cool as lexical search is, it is using a bag of words model underneath, and if you have it phrase matching, but it kind of cuts the corners off semantics of language. Lexical search doesn't get synonyms out of the bag. Is it bark on a tree or the bark of a dog? You can add this information in, but it's challenging. Semantic search, lexical search doesn't get homonyms. That's apparently the one I just said. Synonyms would be like gorilla suit, monkey costume. Lexical search is clueless about negation. You say, don't ever call me again, and it calls you again all the time. Semantic search is missing the contextual clues in the language that we as humans use to modify and understand the intent. And so, in some respects, lexical search, the things that it's not quite as good at are the very things that semantic search excels at. So are we really stuck here? There is hybrid search, but I think hybrid search is often kind of one of these type flavors. There are other things that are appearing right now, and you guys are the smart people that will even tell me what I don't have on this slide. But for example, outside of just lexical search followed by re-ranking, there's things where we're effectively trying to shove semantics into a lexical search engine. Splade is a great example, where effectively we can take the embedding model that we would have used to embed this into a vector database, and we're teasing the vector model to effectively create synthetic synonyms that we can then shove into lexical search. It is a recall play, trying to get as many documents as possible, but it still does treat these synonyms as a bag of words. So it still does have some of the problems. If you go to the opposite side, there is a recent research into this approach called Acorn, which is now kind of sort of in Weaviate. They've apparently modified it. But basically, rather than shoving vector search into the structures of lexical search, they're just trying to take the lexical search and shove it into the hierarchical navigable small world data structure. Effectively, it gives this visitor that's looking through this data structure access to the filters that it can use as it's going through. But I don't think, based on the blog post, I still feel like there's some rough edges on this. And if anyone knows more about it, I would love to hear. And this is kind of like a mystery one. I found this right before I put the slides together. I don't know if anyone has used Superlink. Has anyone used Superlinked by any chance? Yeah, interesting. Somehow they are taking piggybacking off of whatever vector store you want. So they're using the mechanisms to do nearest neighbor search that already exist out there, but in the embedding vector, they're somehow embedding multiple data types and sort of multiple pseudo fields into the embedding. Not quite sure how it works, how well it scales. If your embedding vector is fixed at 1,500 some odd, then does it really make sense to shim like 10 fields into that same address space? I don't know. A lot of questions about that one, but there are at least things happening. And now for my favorite slide. Thank you very much.
We will have time for a couple of questions before everyone rushes out to lunch.
Thank you. Hi, my name is Kathleen. I'm actually from Elastic, so I was happy to see all your Elasticsearch examples. I did have one question. Have you, I noticed that when you were doing your Boolean queries, did you ever try doing a Boolean query combining like KNN with pre-filtering and any additional filters on that? Because I'm curious of if you didn't try that, to do more of a hybrid search and use semantic search along with your filters. I'm curious of why, and if you did, I would like to know why that didn't work for you.
Well, so I have used that just a bit in the past. I'm aware of Elasticsearch's KNN embedding and stuff like that, but it's still, to my understanding, and you can uniquely correct me here, there is still kind of this issue with the internal data structures where we've either got a choice of running hierarchical navigable small worlds and then post filtering, running the risk of kind of filtering everything out, or we can do lexical search and then brute force search the vectors. Now, is that correct me? Give that lady a microphone.
Do support pre-filtering in sorry.
Yep.
No, we actually do support pre-filtering in KNN searches so that you can get the pre-filtering done. It'll happen before you do, before you get your results back. So you don't have to worry about, I want 10 results, I'm only getting 7 back. That's definitely a solved problem, and totally happy if you want to chat like later tonight or something about that. Would love to talk to you a little bit more about some of the things we've done to make it easier.
Yeah, I'd love to.
Alexandra asks, what is the best way to apply hybrid search in real-time scenarios when the latency is critical?
Best time to apply hybrid search in real-time scenarios when the latency is critical. Honestly, I don't have, it depends so much on whatever your domain is, and it depends like what you've tried. Without knowing too much more about the exact details, I don't know if I would be a good candidate to tell you how to tune it. So there's my non-answer answer.
We have time for one more question.
Just another question about your hybrid search strategy. So you said it seemed that on the 2 diagrams you had, you said, are we stuck here? And I was wondering if you had tried having 2 separate queries. So you have your lexical query as well as your semantic query, and then do a re-ranking of both of those so you get the benefits of both.
The are we really stuck here is kind of being addressed by, what was your name?
Kathleen.
Kathleen's response. In this talk, I'm not really worried about merging the 2 types of results. I'm kind of doing an either or for lexical versus semantic, and so that is obviously the thing that you probably should do. But here I'm mostly pointing out the benefits that you have from like the analysis that you can do over the resulting data sets, allowing the model to see the aggregations and self-explore and do things that you can't as easily do with pure semantic search.
Thank you, John.
Thank you.
Let's thank our speaker again.
Have a good lunch, folks.